I'm going to talk today about how to choose a database and some best ways to operate it. And coincidentally, this talk is practically a complimentary talk for the first two of the day. So if you were present on the first two talks by Andrew and Alexander, so they all come together in different ways. And why you want to bother choosing your database? Well, it's the most fundamental thing about your project, and I've seen more times when project switched their programming language than they switched their database. And sometimes when people do not think and just choose something that's cool, they will suffer later. And for example, one project that I worked on a long time ago, and people they used MongoDB for contact relationship management system, which is basically wasn't a good idea even then in 2010 when it was started, and it isn't a good idea now in 2017. So they still suffer. They suffer every day for it. And who wants to bring that on themselves? Right? Nobody. I think so. I hope. And basically, we have different cases. For example, if your project is small, you will do it in 1 month, I don't know, maybe 3 months with 1 or 2 developers. I don't have much advice for you because I never participated in such projects, and you won't suffer 7 years later because if it's done in 1 or 2 months, then it's okay to cut corners. I think so. I don't know, actually. And let's take this case by case. So if you know what you need, right, it's some huge time series database, or you need cross-data center replication or some other stuff, this talk is not for you. And but probably Python is not for you too, so you are not here. Okay. If the tech is really cool, right, it's a new, shiny, interesting thing, and it's totally okay to experiment at home with it if you want to learn this new shiny stuff. If you want to do something other and you need a database for the thing that you are working on, I would advise to use something that works and not a shiny thing that will just make you suffer a bit and will stop you sometimes from working on the exciting part. And but sometimes it can, some new, shiny, interesting thing can give you an actual business advantage. For example, real-time streams in ResyncDB. I haven't used them, but I've seen when people were praising them and they didn't need to implement all the stuff by themselves, and they just used it, and probably for their case it was better. And for example, I know, time travel in some databases. And if you really want to have a time travel, maybe it's good to have it in your database and to implement it on top of the database on application level. But in all cases, what you need to consider? You need to consider many things, all this stuff like data correctness, how easy it is to fit your data in the database, how complex, how hard it is to operate it. You don't want to spend a third of your time just tuning your database. You don't want to figuring out why is it running out of memory, or why is it some replica has died, and so we will tackle this bit by bit. And I also want to emphasize that Andrew mentioned at the last point in his talk that basically you don't know what you need to do. and this is a big part of it, right? So data correctness is it's very important because you don't want to learn after half a year or I don't know, year and a half in production that your database was silently trimming some field that you were putting there. For example, you had some I don't know, email URL that was that had 30 or 50 characters length, and the data was even, I don't know, 300 characters long, 1 kilobyte long, and all the tail was just stripped, and you didn't know it. And after a year and a half, you find out, and it's not a great moment, right? Schemaless, it's a thing that doesn't basically exist, right? Because you just have many schemas in your database, and you don't know which schemas you have there. So it complicates very much analysis of the data. It complicates very much display, and it's really hard to migrate this data because it is in different shapes, and I don't have, I can't just give you an example on the fly, but I hope you can imagine that. And the next point is data modeling. So the thing is that for document-oriented databases like MongoDB or I know, RethinkDB, you have to put the data in, if you want to read it a lot, you have to put it there in the way that will be easy to get out. So you, for example, if MongoDB it doesn't have secondary indexes, you need to construct everything and use one particular index. So your queries will take out the data that you need, and it complicates stuff. And in relational database management, you can just put the data there if it's adequate, because if it's, well, with sufficient will and energy, you can cripple any data store with metadata pairs, and it will suck for any database, right? But generally, it's easier in relational databases. And Datomic is a kind of special database because it's really the one that where you don't have to think about it a lot. You don't have to think at all, because you just put data there in triples, and it just works, and you can query it like a relational database, you can query it like a graph database, and it's amazing. But it's also a commercial database which costs some money, and we love open source here, so I won't advertise it much. The next point is migrations, and the migrations are often overlooked part of all these databases, and because I don't know why. And some points here, especially this one, keep them in repository, may be very obvious to you, but I've seen a project where guys were doing this. They used auto migration to create migrations in Django, and they put this migration folder in gitignore, and they did auto migrate on every developer box and also on production. So all things were a bit different on every machine, and it was kind of scary and amazing. So this is where I got this part. Transactional, the DDL, transactional data domain language, I think, is a cool part of Postgres, because you can open Postgres shell, PSQL, and type begin, start a transaction, do some alter tables, do some create tables, drop tables, and then you can just roll back it if you screw it up, and make begin, and basically you're developing, you can develop migration in, not transactions, migrations, sorry. So you can basically develop migrations in REPL, which is how we develop our Python code, or I don't know, Clojure code or whatever. And it brings such a joy after you've been using some, I don't know, MongoDB, because in MongoDB, how you do migrations, you basically how we did migrations. We try to do we write some migration, try it on our developer machine. Okay, it doesn't work. It crippled our database. I need to drop database or restore it. Okay, I do that again and again and again with drop database, restore database until it's good on my machine. Then I need to run it on staging. Okay, it's been put on staging. It runs there for 1 day. It dies. Oh, cool. We need to restore database on staging, fix migration, run it on staging again. It runs for 2 days. It dies. We need to restore database there again, fix it. Okay, we push it into staging. It runs for 3 days there. Okay, it's good. And then it's been pushed to production, and it runs for 3 days there. And it's not usually these migrations. It's not like it was done in a week. No, it was like deployed in a week, and we had, for example, 2 months of work before that to change our application code. And also one small thing about downgrade migrations. I never did them. I don't know of anyone who ever did them on big project, and basically don't spend time on them, because for complex cases you can't use them, and for simple cases you don't need them. So just don't spend time on them. One thing about migration tools, like we have migration tool in Django that was a South, and now it's just Django migrations. And we have Alembic for SQL Alchemy. I really don't like auto migration stuff there, and because of this, for if we have some simple task, we need to add a row, we need to delete some row, it works great. You just do auto migration and it works. You don't need to learn anything, and you're here with migration tool. But then you need to, and if you have a native migration we've written in SQL or Cassandra query language or something, you need to learn the SQL or Cassandra query language, right? And you need to write alter by hand, so it's a bit harder. But for a more complex migration, you already know your alter tables, you know alter column and stuff, and it gets a bit harder for more complex migration. And for data ORM migration tools, you need to learn at once for everything that you need here, because you basically need to try to develop this transaction. And after that, you need to map it onto the tool, and you need to learn and read 20 pages of documentation of Django, for example, a few times to understand what's written there and to understand all cases. So I don't like them, and I would advise to use something like Nomad and Migrate. These links will be clickable in the slides that will be posted later. And they just store migrations like a simple files for SQL, Cassandra, query language, and others. And this slide, it's a bit obvious, because I don't think there are many ways to do complex migrations. So if you ever needed to do it, you probably did it like this. And if you didn't do it, but you will need to do it, you will probably think of this even if you didn't read it, anything, but basically it's goes like this, and it works for any kind of migration. If you want to migrate to other table, if you want to migrate to other database, I don't know, if you want to migrate to a new version of Elasticsearch, you just spin the new one, then you set up your code and deploy your code that reads from the old place and writes to the new place, and writes to both. Then you migrate all the data from the old place to new place, and it's the same in both places. You read from both and compare if it's the same. If it's not the same, and it's usually not the same, you fix all the stuff, do it again, check, double check, triple check everything if it's really important, and then you truncate all the stuff that's not needed, old code, all the tables, all the Elasticsearch. And well, that's it for migrations, I think. But one thing is, if you do migrations in Postgres or MySQL, where you have locks when you migrate table, be careful not to lock your table for 7 hours or 2 days and go on vacation, because people won't like that. So that's it for migrations. Let's get to the next step, performance. When you need to squeeze when you need to get performance out of your database, and when you have a lot of requests or you have a lot of data and you have your data model starts to matter here. So you can just actually dump it into Postgres and make it work. So sometimes you need to think about how to lay it better. And the first thing that you need to do is to read documentation of your database of choice. If it's Postgres, I don't know, MongoDB, anything, you just need to read documentation to learn how it works on the low level. Because low level is very important here, and depending on how you laid out your stuff, your data in database, it can give you some orders of magnitude of difference. For example, in Postgres, this toast, right? So what's toast? Well, it's the best in sliced bread, right? And actually, in Postgres, it's kind of the same, but it's the oversized attribute storage technique. So if your field is really big, and for Postgres, I think really big starts from 2 kilobytes, it's been put not in the same page of the database that an actual row is stored, but it's been put in the other additional file, and it's for example, when you start to query this database and you query this field that's stored somewhere else, you have random reads on your disk, and it's sometimes you go from 3 queries, 3 disk 6 when you have when you query only rows that are being stored in the table, to, for example, like 50 disk reads when you are accessing this toast fields. So there are a lot of such things that you want to learn, right? Different index types. For example, when you start to shard your database, you need to know everything about the sharding hash range, sharding key. Andrews talked a lot about this, and I don't have anything more than that in my talk. And you also need to know your tools that to understand what's going on to fix your performance. So it's like monitoring, log slow queries, how you can do that in your database. You need to use explain, and explain, as Alexander said in his talk, it's, for example, in Postgres it's awesome, and it displays everything, and other databases not so much. Even MySQL, as I remember, has much worse explain than Postgres, and for Elasticsearch it's horrible, right? Sometimes you need to use other tools, not particularly database tools. For example, this IO top that will just display to you that your database is spending all the time just looking at your disk and not actually computing something. And the next thing is, of course, ORM. I won't repeat many things that were said today about ORM. I will give you an example of this data overfetch. Yes, for example, this is from my project, a small piece of code, right? We get some object with an ID, and we store some mapping easily, right? It's very convenient to write code in this way. What could possibly go wrong? Well, it turns out we have lots of data in clusters, and it runs for 50 seconds. So how can we do better than that, right? We can only query the fields that we need, and it is much faster. And we just, with just 50 megabytes of RAM instead of 11 gigabytes, I could take it anytime. And we can even do a bit better if we want to enable some streaming stuff. This is a SQL alchemy, so we don't store anything at all here. Well, like not anything, just 1,000 of them. And it's a bit slower, 4.2 seconds, but it consumes even less RAM. So that's cool. So with proper tools, with knowing low-level details of your database and laying out your data in proper way, writing proper queries, using all explain stuff, you can defer the next step for years, right? You don't need to scale it that much. And well, as Andrew said, distributed is really hard, and I also want to add some more scary stuff, because this Jepsen link is about Jepsen testing tool that was created by Kyle Kingsbury with nickname Afir, who just used this Jepsen to break distributed databases. So basically, he took any distributed database and he broke it with his tool. The only database that was working correctly even before Jepsen was a Zookeeper, right? Any other MongoDB, RacinDB, Cassandra, Kafka, Aerospike, Elasticsearch, lots of them, everything was broken by him. Fortunately, it's becoming a bit better now because of his work, and now it's a bit better, right? Sometimes it's much better. Another stuff that very fresh stuff is this course, and the people, what they did is they tested 8 different distributed databases, and they tried to insert one small error in their on the disk. So they crippled one, I don't remember, 1 bit or 1 byte of their disks, and they broke everything. They broke Kafka, they broke Zookeeper, they broke MongoDB. And so the best part, I think, was Redis, because with Redis, they inserted this wrong bit, and Redis discovered an error and said, wow, that's an error, and killed all the database on the master and on the slave. And that's fault tolerance, right? And basically, do you need to distribute when you can just buy bigger server, right? For example, when I needed bigger, I needed bigger server, or I needed to scale. My 32 gigabytes was not enough, so I just went to Hetzner and rented a 250 gigabytes server for 100 euros, right? Of course, on Amazon RDS, it would cost $2,000, but Hetzner is good, and I just spending 100 euros per month for that. It's cool. But what if you need bigger scale, right? Well, I don't know, by bigger server, even bigger server. If my 250 gigabytes will not be enough, I can just go and buy 760 gigabytes with more processor. But what if you need even bigger scale? Well, I don't know, by the time you probably will know what you need. You probably will do what Andrew described it in his talk. You will need to hire hundreds of engineers to battle all this stuff. Probably, I don't know. And what can you use there? If you can use some horizontally scalable systems like Citus. Citus actually is a pretty cool thing. It's basically a Postgres extension that provides you horizontal scalability inside Postgres. Pretty cool stuff. I haven't tried it because it fits on one server, but I plan to do it in probably a couple of years. And how you do that? You pull out data bit by bit, or I know, service by service, everything. I find that I constantly refer to Andrew's talk, but it's a bit funny. Did we forget something? No? Maybe it's availability, right? So what with availability is it's a big word, right? And it means two different things. For example, it means that it has its meaning inside CAP theorem, and it has its meaning like I know I have a slave server. So when we have some solution with master slave, it's not really available until you have tested it, because some databases like Redis will so this is a tale from Modna Casta. They had this Redis that was storing user sessions, and they had master and slave, and they needed to reboot slave server, not Redis server, but the actual box. They rebooted it, and master Redis said, "Where is my slave? I won't answer anything until my slave will be available." So basically it died for several minutes, which is not really an available behavior. You know, why do you have this master and slave? Because if one dies, then others should continue to serve you, and you need to test it. Services, this first point is actually quite funny one, because services don't usually go offline because your database suddenly is unavailable because, I don't know, you have network split between your code and your database. For example, if you remember, not a long time ago, Amazon went down, like S3, simple storage service went down, and a lot of stuff went down. And it wasn't their database, right? It was some third-party service. Probably they had more downtime from S3 than they had from their database running wild. I'm not saying that you don't need to do it, but you need to consider if you need to do it, because for some scale, for some projects you need it, and for some you don't. I don't need it because my service will be fine if it won't serve someone for 5 minutes, and for some e-commerce it's a bit harder. And about availability in the CAP sense, like consistency, availability, partition tolerance, don't ever do it, because well, do it if you don't need consistency, right? Because, for example, some people say this, I've got 2 megabytes JSONs in my CouchDB. It's a document-oriented store available. So, for example, it was split, and now I have 2 different JSONs with my very precious data, and now I somehow need to merge them, and it's a pain in the ass to merge 2 very complex documents. And why did you did that to yourself? I don't know. So basically, this I would say that when you need to use a database with A from CAP theorem is when you just throw data at it and it doesn't change ever. So you can put your logs there, right? And it doesn't matter if for, I don't know, 10 seconds one shard didn't know what the other shard got. But for storing your the data that you would like to have transactions, for example, it's really not the best way to spend your resources and the thinking time. One small thing is that we have some things that we just don't put in databases. For example, not many people put images in their Postgres or whatever. Machine learning models that can be from 3 megabytes to 3 gigabytes. People usually don't put into databases as well, so it's residing somewhere on the disk or on a tree, and you need to cache it locally. And this is stuff that prevents you from scaling your workers, from scaling stateless state that needs this state on the disk locally. And basically that's it. So we have conclusions here. If you want to experiment, better do it at home or with some very small scoped project. Don't bring a new database in a big project just because it's interesting. And if you're not sure, use Postgres. It's really cool. Thank you. Any questions?
Thank you for your talk. I believe at some point when talking about schemas and migrations, you mentioned that how you like alter in like SQL systems comparing to non-schema systems like Mongo.
Yes.
And how you specifically how you like the fact that it will, like if you change the type of column, like it will migrate the data for you. Like if you change the, I don't know, the length of varchar column or something like that, or like just completely apply any function to change, like, I don't know, from int to string or whatever. But what we ended up with in our project, that at some point it just doesn't work in a sense that all these alters usually like completely log the table for writes, and this is not acceptable if it's like it is logged for a long time, like 10 minutes or so. Just to give an example, when Rackspace ran migrations for like their database in OpenStack, it just completely logged their database for 2 hours, and like that's that's when we understood that we're doing something wrong, and what we ended up with, we just completely separated data and schema migration. So the only migrations allowed are schema migrations that do not touch data, and you just, in our system, you just can change the type of a column. You add a new column, and then you add complexity to your code that just migrates it over time. So we're doing more work, but we're doing it over a long period of time. And yeah, just a brief remark.
Yeah, that's right.
Okay.
I completely agree. If you can't block it and your migration blocks it, you need to do it differently, like this, like you said.
Yeah, I'm not sure about Postgres, but recent versions of MySQL actually they have this table with for each operation, for each alter, they state whether it's locking, whether it like creates a new table in the background or not. So I'm not. I believe Postgres is must be the same. I hope so.
You have in the Postgres documentation, you have all you can find the place where they say which queries, what log do they acquire, and with what queries do they block.
Thank you. I just hope that like most things like adding new columns can be done online without any locking.
Yep.
Thank you.
Okay, thank you.